welcome back. The seventh type of function that we're going to see in the classification of functions is on my first video to learn to understand and graph and get the logic of basic functions. It's going to be logarithmic and exponential functions, okay? The names sound, ooh, something like Jason is coming, Freddy is coming, the predator is coming, something really scary. But in reality, they are not. You just have to understand the logic behind them and get the meaning, the reasoning that is going on with them. And once you're able to get past through that stage, everything else just flows naturally, as you heard me said before in the past videos, okay? So the first item that we're going to cover, as you can see, I pretty much divided the board into two halves, logarithmic and exponentials. So the first part, I'm going to talk about logarithmic functions. Okay, you probably saw a little bit about this in high school or in the first week of college. Logarithmic basically is just a very big, messed up, confused question. If we have logarithmic based on a of x equals b, in reality, what's happening is that the question being asked is a very rare one. What should be a's exponent so I can get x? And a's exponent is, of course, b. That's the question being asked, okay? What should the exponent of a be so I can get x, okay? So in essence, let's say you have something like logarithmic and the base is 10, okay? And let's say I'm asking for the logarithmic of 1, what is the degree that 10 has to have so that I can get 1, okay? And that's something that is pretty logic, right? If I have 10, and 10 is my base, what has to be the exponent of 10 so that I get 1? What is the only number that I can power 10 and get 1 as an answer? 0. That's it. Anything powered to 0 is 1. Oh, that 0 ended up pretty ugly. Okay? What should a's exponent be so that I can get 1? 0. That's the question that is being asked, okay? And logarithmics, and any kind of logarithm, okay? And you have logarithmic base 10, and you're going to have natural logarithmic, which the base is the e number, which we're going to see in a few seconds, okay? So the function of logarithmic of x, and in general, pretty much every logarithmic function and its variance is going to look a little bit like this, okay? Let's say we have the x-y axis right here. Well, the logarithmic function is pretty much going to stay on the right side of the axis, okay? There's going to be a cut, an intercept, at the point with coordinates 1, 0, x, 1, y, 0, and then it's going to keep growing up, okay? Keep going up, okay? Pretty much steady grow. It's going to keep on the right side of the axis, okay? Unless, of course, unless there is a displacement, an operation with the variable, as you may have seen in the videos where I added and subtracted k to the variable. Well, in that case, well, the logarithm can move a little bit to the left or the right or up and down. But in essence, the essential graph is going to look a little bit like this, okay? And these are stuff that you have to memorize. You have to know just like that, okay? The right side is what is called the mirror of the logarithmic. It's called exponential functions, and that is a little bit easier to explain, okay? The main question that is being asked right here is just, well, just give me y if I give you a number and I power it, and I want to know that variable, okay? So e is the Euler number, which is given to society, but to honor mathematician, one of the greatest mathematicians of all time, and one of my preferred ones, Leonhard Euler, okay? And it's 2.71, and it goes on and on and on. It's a very, very long number. It's not a rational number. It's pretty much the same essence as pi, okay? But let's keep with 271. And exponential, it's like the main essence of the definition of function. But in general, as I write right here, you can have a powered to x, okay? And a is a real number. So for instance, you can have something like, I don't know, let's write it right here. You can have something like 2 power to x, okay? And the variable is x, and you know, you just keep borrowing 2 to 1, 2 to 2, 2 to 3, 2 borrowed to 4, 2 borrowed to 5, and so on. Okay, but you can have something like 8. Okay, 8 to x. Okay, in general, you can have a as a real number borrowed to a variable. That's pretty much the same thing. But you're going to stick to the ex because ex is e borrowed to x. You know, the exponential function is going to be pretty much the main base in all calculus and all college. Okay, the graph for exponential function is pretty much like this. If you take a quick look at it, you know, just a glance and compare it to the logarithmic graph, it looks like they're mirroring each other, and in fact they are. Okay, if you were to draw an imaginary mirror right here across the exact diagonal of the axis, well, the exponential function would be mirroring the logarithmic function, pretty much like that. Okay, they would be kind of mirroring each other. It may not be my best drawing, but you pretty much get the essence. Okay, they're kind of mirroring each other, and it makes sense because they are inverse when the base is the same. Okay, there's an intercept cut at the y-axis at point coordinates 0, 1, x 0, y 1, and that's about it. The function pretty much remains in the positive side of the y-axis, so it's always positive, and it makes sense, right? Because if I have a number and I'm borrowing it, it doesn't matter what the exponent is, the sign, the number, the degree, whatever. Okay, it's pretty much always going to be positive because if I have, let's say, e borrowed to 0 is going to be 1, hence the intercept. If I have e borrowed to 2, well, it's a positive number. It's going to have whatever. E borrowed to 4, e borrowed to 10, and so on. And even if it's a negative number, the result is still going to be positive because you're going to have something like y, e borrowed to -2, for example, and all this is just simply 1 over e squared. This is still a positive number, okay? So you're going to have here e borrowed to -20, and all this is just 1 over e borrowed to 20. It's still a positive number, hence it's always on the positive side of the y-axis, okay? So that's pretty much it. Like I said with the logarithmics, the main essence of the graph looks like this, and unless there is like a displacement to the function or to the overall variable, you know, maybe moving a little bit up, down, left, sideways, it's going to pretty much look like this, okay? Of course, there are going to be a little bit of more complicated examples as you move on in your further courses, but that's the subject of another video, okay? For now, that is logarithmics and exponential functions. Remember, comments or any feedback, send me an email to helpmegraduate.com, Hector@helpmegraduate.com, or simply comment in the comment section of my videos. Take care.